Hello Science 30s. In this video, I'm going to be breaking down some major pollutants that you need to know about in Science 30. In this video, we're going to be talking about halogenated hydrocarbons, benzene, acid deposition, smog, and ground level ozone. We're first going to get into halogenated hydrocarbons and benzene. So first of all, we'll talk about benzene actually. So benzene, you might also remember, is known as the aromatics, and it is also known as the phenyl ring. And so the sources of benzene that you need to know about are petroleum, coal, natural gas, and cigarette smoke. So petroleum, basically what happens with benzene is that it comes from the incomplete combustion of these top three things, first of all. So the incomplete combustion, and it's also important to realize that we in Canada and a lot of countries around the world have a lot of laws around the exposure and how much benzene is allowed in these products. Our gasoline in our cars, for example, no more than 1% of our gasoline is allowed to be benzene by law now. And that's been the case for a while. Another major source of benzene is cigarette smoke. And in fact, half of all benzene exposure comes from cigarette smoke, according to a study done in the United States. What you'll find is that what's interesting about the benzene in cigarette smoke is that it is higher in secondhand smoke than it is in firsthand smoke. And you will also see that houses of smokers have much higher benzene levels than non-smokers. The stability of benzene, normally when we talked about double bonds before with saturated fats, for example, or unsaturated fats, with unsaturated fats, we learned that the double bond actually makes the chemical a little bit easier to break down. In benzene, because of the ring structure, it makes it nearly it can last for hundreds or thousands of years in the environment without breaking down. And that leads to a name that is called the persistent organic pollutant. So right here, persistent organic pollutant, which we also just call the POP. And so those are POPs, persistent organic pollutants, are any benzene-based molecule that will negatively affect the environment. And the effects of benzene are mostly that it's going to threaten the health of plants, animals, and humans. If we turn our attention now to halogenated hydrocarbons, we've talked about these obviously, just like benzene with the structures, but now we're going to get into a little bit more of the effects. And just to review some of the sources, so we have the CFCs, which is refrigeration. So this is for refrigeration purposes. We have pesticides, which is things like DDT, and not even just DDT. A lot of other pesticides do contain halogenated hydrocarbons as well. We have PCBs, which are used in electronics. And yeah, so and then we also have plastics, paints, solvents, a lot of the other things that we've heard before for organic pollutants. The effects of these are going to be holes in the ozone layer through the release of free radicals. And so free radicals are going to be those chlorine, the chlorine that breaks off from the rest of that organic molecule. This will break off of the molecule, and now this chlorine is free to roam around and affect the environment and human health as well. So benzene and halogenated hydrocarbons are two separate types of chemicals. However, we often do see them working together, and they're not mutually exclusive. And so if we take a look at some of these molecules I have on the side here, we have DDT, and you can see the benzene right there, and then we have some chlorines. And so this is a combination of benzene and a halogenated hydrocarbon. We have the PCBs right here. Here's our PCBs, and we have chlorines, and we have benzenes. Dioxins, we have benzenes and we have chlorines. And furans, we have benzenes and we have chlorines. And so they're not mutually exclusive. And one of the other major effects of these is going to be biomagnification. So this diagram is taken from page 260 of your textbook, and you'll see that we've talked about biomagnification before, but this is basically these chemicals will just build up in the food chains and food webs of the ecosystem, and so therefore the animals that are at the highest levels of the food chains and food webs are the greatest affected by this. And we've talked about that before, so I'm not going to get too much more into that. And now I just want to talk about a little Canadian connection here with these, and that is the prevention of damage from these halogenated hydrocarbons and benzenes. And in 1987, there was a meeting in Montreal, and it was called the Montreal Protocol. And you can see there, this was a multi-decade agreement that immediately, immediate when it comes to the terms of the government, banned things like halons by 1994. Banned things like CFCs by 1996, banned bromomethanes by 2010, and then the goal is to ban HCFCs by the year 2030. And so by doing this, hopefully we see a lot less damage from these types of chemicals. And in fact, we already have seen recovery of the ozone layer to some extent at this point. The next topic that we're going to talk about is acid deposition. So we already know what causes acid deposition, and those are both your SOXs and your NOXs leading to acid deposition. And what we're going to talk about is now some technologies that we have and are utilizing that will reduce the amount of SOXs and NOXs entering the environment. First of all is electrostatic precipitation. So what happens when we burn and we refine petroleum? A lot of our petroleum is locked up in sands. And so when we refine that, we actually release a lot of the sand particles back into the air. And those sand particles contain SOXs and NOXs. So it is a dry type of deposition that happens. And what the electrostatic precipitation will do is they're put right into the smokestacks, and they use electricity, and they attract the sand to the sides, and they just basically filter that smoke out. And then that prevents the SOXs and NOXs from entering the environment. I didn't write that in, but they prevent them from entering the atmosphere. And so that's what happens with the electrostatic precipitation. And if you want to see a diagram of that, there is going to be a diagram in your textbook on that. So please check that out there. The next technology we have is scrubbing. And scrubbing, now this is where you need to know these specifics. And so you need to know that scrubbing removes SO2s from the combustion of coal. We talked about in class before classes were canceled that SO2s come from the combustion of dirty coal or even dirty natural gas. And scrubbing is just going to be a chemical process that removes that. And so it makes the pollution that is entering the environment in a way a lot better than it could be. And the last thing that we're going to talk about today for acid deposition anyways is going to be catalysts. And so catalysts, things like in your car, you might have heard of a catalytic, pen's not working great here, catalytic converter. This is not great at all. There we go. Okay, catalytic converter. And so we have a catalytic converter, and the catalytic converter, once again, check it out in your textbook if you want to see diagrams of it, but that's going to remove NOXs from pollution. And so you have scrubbing, which removes SOXs, you have catalysts, which remove NOXs, and you have electrostatic precipitation, which remove both. And the last thing we're talking about today is smog and ozone. And what we need to realize here is just what causes it. and how we can reduce it. So again, smog and ozone, guys, comes from NOx's and not SOx's. Only the NOx's cause smog and ozone, or sorry, smog. And then the NOx is going to cause a reaction. I'm not going to get into all the reactions that happen, but the NOx's basically are going to create ozone. We are not talking about ozone at the ozone layer and the stratosphere. We are talking about ozone at ground level. Ground level ozone is not great. It's not great for the health of plants, and it's not great for the health of animals either. And you can see in this picture here the difference between a high smog day and a low smog day. Here in Edmonton, we don't get a lot of smog. We're just not in a great location for it. More so cities that are built in valleys, and there are a lot of big cities built in valleys around the world. Mexico City, Los Angeles, and a lot of big cities are built in valleys. And a lot of those cities just are smoggy all the time. And it comes down to those NOx's. So we know cars don't burn. Well, they burn hot enough to burn the nitrogen in the air, which makes the NOx's, and then we try and capture that with the catalytic converters, remember, to remove that from the pollution. And but it's not 100%, and so a lot of those NOx's do build up, and we do get things like smog. And so I hope this video helps you with the pollutant summary. It's probably just a start, but I hope it kind of gets you started as to where you can maybe find some information, some of the types of things I want you to fill out for that pollutant summary chart. If you guys have any more questions, please email them to me and let me know. And this will be your only video of the week. Thank you.